All right, guys, so today's lesson is on something called compound interest. It's a special application of exponential functions. So, first of all, guys, let's talk about what interest is. Some of you probably already know what that is, but just in case, I'll give you a little explanation of what interest is. So, in this world, sometimes things are too expensive for us to afford, so we borrow money from people. Okay? It's like you want to buy a house, no one's going to be like, all right, just a second, 200,000, 300,000, you say? Nobody does that, right? You borrow money from a bank, and they loan you money. The thing is, they're not giving you that money for free, loaning that to you for free. They charge you for it, and they charge you a certain percentage. Like right now, Miss Rose is telling me like her son just bought a house, and his percentage rate will be about 5%. Okay. Now, interestingly enough, the way interest works out, it's a pretty scary thing. By the time you pay for something, sometimes you'll end up paying probably about 3 or 4 times the cost of the original thing itself. And one of the worst things you could do in your life is not use credit cards wisely. Credit cards, the only reason why you should get one is to maybe build reward points or something. You never use a credit card and just live off of it. You will destroy your economic life. So don't do that. They're bad. They have like the worst interest rate. They charge really high fees. I've seen people destroy their lives with credit cards. What a lot of people do, like Mr. Norris, he's smart with money, is they'll use credit cards because they give you reward points for like maybe travel or something. But the point is, you use your credit card, you get your reward points, you go home and you pay it off completely right away. If you keep it for a month, they tack on interest, and then it gets bad. Like, I've actually been told, like, if you just pay the baseline, like they send you a bill every month, pay this much. If you just pay what they ask you to pay, you will never pay it off because the amount they keep adding on grows faster than the amount which you're paying back, and so they'll just keep drawing money from you forever. So interest is good. We need help, but it could also be pretty detrimental. Now, sometimes interest works in your favor. Like you can invest money in stock, you can invest money in banks, and they're grateful to have your money, so they'll give you interest on that because you're sharing your money with them. And so that's what interest is. Okay, so let's talk about that today. This process of doing interest has something to do with exponential functions, and you'll see that a little bit later as we move on. So suppose you want to invest $1,000 at a bank, and you have 3 banks to choose from. Now, at first, they all seem like they're the same because they all say, we'll give you 20% per year. In other words, whatever you put in, they're going to add on an additional 20% for letting them hold on to your money for a year. So they'll give you 20% per year. But these 3 banks do it in a different way. This bank will give you 20% of what you invested once at the end of the year. So here's $1,000, a whole year goes by, boom, 20%. Thank you for sharing that with us. The other bank will give you 10% in the middle of the year and the other 10% at the end. Okay? The last bank over here on the end will give you 5% 4 times. In the first quarter, they'll give you 5%, next quarter 5%, next quarter 5%, and then finally another 5%. But that still makes 20, right? Now you would think, well, they're all 20%, so that's the same. It's not, and I'll show you why. So first of all, let's do. So I have $1,000, right? I'm putting $1,000 into an account, and let's say that 1 year goes by, and they're going to give me that percentage. Now, if they're giving me 20% extra, what do I multiply this by to find out what an additional 20% would be? 1.2, right? 0.2 is 20%. But if you want to add 20%, it's 1 plus 0.2, which is 1.2. So we're going to multiply this by 1.2, and that gives me $1,200. So at the end of the year, I'll have earned an extra $200. Not that impressive, but something anyway. Next, let's take a look at bank number 2. Bank number 2 is going to do it a little bit differently. We put our money in at the beginning, and halfway through the year, we get our first interest given to us. And what percentage are they giving me? 10. So I would multiply this by what then? 1.1. Okay? And that would be 1,100. And then the other half of the year goes by and they do it again. Now they're going to give me another 10%. So I multiply this by 1.1 again. And I don't remember the answer. Can someone do it on a calculator for me? What's 1,100 times 1.1? 1210. Okay, so let's take a look here. Let's compare Bank 1 and Bank 2. Which one gave us more? Bank 2 did. It's not impressive. It's $10, but hey, it's still more. Okay. Can somebody explain why? Why did this bank end up giving us more than this if they both gave me 20%? This just gave me 10%, 10%. This one gave me 20%. Isn't that 20? Yeah. More years? This is all 1 year. So what these numbers over here represent is how many times they give you interest. So this is no interest. This is one time they gave me interest. This here is no interest. This is the first time they gave me interest, the second time. But this second banker, they gave me interest twice throughout the year. So that's not quite it, but that was a good guess. Any other thoughts? Why does this one end up being more? So let me help you guys out a little bit. What's 10% of 1,000? 100? And so 20% is twice as much, right? So how much is that? 200, right? So they added on an additional 200. 10% is 100. Do that twice, that's 200. So it's 1,200, right? Well, over here though, take a look. I took 10% of 1,000 and they added on 100, right? What did I take 10% of this time though? 1,000? 1,100. So now they're giving me 10%, not this second time they did it. They're not giving me 10% of 1,000 again. They're giving me 10% of 1,100. So in other words, you're making money on the money they already paid you. Does that make sense? So they gave you money, and now they're giving you interest on top of the interest that they already gave you. So that's called compounded interest. Now, you guys recognize this is an exponential function, right? Because you're multiplying by the same number and over and over again. So, what's my starting amount? It's 1,000. What's my growth factor? For this one, it's 1.1, right? So there's my exponential function. If you were to plug in 2, it would give you 1210. Now, let's do this one. Do you guys think this will be more or less? Yeah, it makes sense. If breaking it up into 2 made more, well, breaking it up into 4 pieces should make even more. So let's see. Now, instead of doing it with a table, though, I'm going to use the exponential model this time. What's my starting amount? 1,000. Now, this time, my growth factor is going to be what? Over here it was 1.2. Here it was 1.1. What's it going to be here? 1.05. And how many times do we get this? 4 times. So let's punch that into our calculator and see what we get. Type that in and see what you guys get. Did you do it, Lil? Oh. Did you get it or no? Did you get it, Brianna? Jessica? What did you get? 12.15. Is there any 10? Okay, I'll just round to 63. All right. So sure enough, that did come out to be more. Now, this really isn't that impressive. Over here, this bank gave me 1,200. This one gave me 12.15. So I made $15 more. Yay. Now we can go to Del Taco or something, or Taco Bell, and get a burrito. But the point is that the more times it's broke, here's what I want you guys to walk away from with this, is the more times it's broken apart, the more it increases. But here's another thing I want you to pay attention to. This is kind of preparing you for our lesson on Thursday. How much did it increase from here to here? What's the difference between those two? $10. How about from here to here? Only 5. So it does increase the more times you break it up, but the increase gets smaller and smaller and smaller and smaller, and that's because as you break up your 20, your percentage gets smaller and smaller. So actually what happens is the value increases, but at a slower and slower rate, and eventually it will level off. And there's a limit that it will reach. And that limit has to do with a number that we're going to learn, like I said, on Thursday, called E. It's a number. It's like pi. It's some weird number like 2.71. But it has something to do with that. And that would be the maximum amount that it could possibly create. But we'll get to that another day. In the meantime, I want you guys to understand the formula. So we have a starting amount. You don't need to write this, but we have a starting amount. And we're multiplying it by a growth factor. Growth factor is always going to be 1 plus something. In this case, it was 20%. In this case, it was 10. In this case, it was 5. So what we do is we take the percentage that they give you, which we call R, and you're going to divide it by however many times you want to. So like, for instance, twice, 20 divided by 2 is 10. So, or 20 divided by 4 is 5. So you're going to take your percentage and divide it up a certain number of times. That's how many pieces you're going for. And that also is how many times you get that interest, and that's your power that goes there. Now, on this one over here, how many times did we do it? 4 times. But that was just for 1 year. What if I did it for 2 years? Now how many times would it be? 8. 3 years? 12. So basically, you just take the number of times and multiply it by the number of years. And this is a formula now that will tell you the final amount of money you would have if you invest this money at this percent being broken up this many times over this many years. Now, if it were up to me, I would just put equals y here, but we're going to use a because that's what most textbooks and stuff use when they're talking about this formula. It's called the compound interest formula. But I also want to draw you guys' attention to the similarity that this shares with our other functions that we've looked at. I'm just using different letters. We saw this one last time, right? Pretty similar. Both of these represent a starting amount. The one's exactly the same. We're never going to put subtraction on these problems. It's always addition. They both have an R, it's just that this one's getting split up into pieces. And they both have an exponent. Okay? So they're both the same function. It's just that this one's a little bit more nuanced. All right. So let's go ahead and I gave you guys this slide. That's why I say you have to write it. But I want you to know what all these things represent. A represents the final amount. P represents the starting amount because in the world of finance, the starting amount is what's called the principal amount. R represents your interest rate. N represents how many times it's compounded. T represents how many years have gone by. Okay? So that's compound interest. And now we're going to work on some example problems. And I just lost my signal, so you guys can sit tight for a second. But I think our examples are in the back of your notes, if I'm not mistaken. So if you just flip it over, they should be there. My screen turned off for some reason, so it'll just take me a second. I'll be right back with you guys. Technology is so weird. It all of a sudden just turned off for no reason. All right. Okay, guys. So just so you guys know, on this test that's coming up, you're going to have 4 different types of word problems. We've already learned 2 of them. This is a 3rd one. Now, once we learn the 4th one, I'll show you how you can tell which type of problem you're looking at. But for today, here's what I'll tell you. How do you know you're going to be using this formula instead of the other things that we've been doing with word problems? How are you going to know that we're using this? Well, because there's a key word up here. Do you guys know what the key word is? Compounded. When you guys see the word compounded, that's the compound interest formula. Now, unfortunately, we're going to learn another formula which also has the word compounded, but it has another special word in there. We'll learn how to tell them apart later. But for now, compounded is your key word. All right, so the first thing I like to do is I like to go through and just read this and then label these numbers that they give me with what letter they are. So, Sarah Wong invested this. That's the starting amount. So that would be P, the principal amount. She invested that much in a retirement account with a fixed annual interest rate of 3%. Well, that's my interest rate. And I'm going to change that to a decimal, by the way. So what would that be as a decimal? 0.03, sure. And it's compounded 12 times a year. That is my N value. That's kind of our new one there. Try to put this back down at the bottom. But this 12, the number that comes after the word compounded, that's your N value. So N is 12. The question is, what will the account balance be after 16 years? There's your time. Okay, so now we just got to plug these things into the formula where they go. So I don't know what A is because I'm looking for the final amount. P is my starting amount, which I've already labeled up here, 31.37. R is my interest rate, which is over here, 0.03. N, we said, is 12. That's how many pieces they're breaking it up into over the year. And N also goes here. And then we'll do T, which is 16. Okay. I'm going to show you guys two ways to do this. One way is faster and more accurate. The other way is slower and you'll be close but not point on. The reason I want to show you the other one is because unless you have a calculator like this at home, you wouldn't be able to type it in like that. So I'm going to show you guys the longer way that's less accurate first, just so you guys know how to do it on your phones at home, okay? So first of all, you're going to do this first. So what's 0.03 divided by 12? Go ahead. 0.03 divided by 12. I'll call on people to share out because 0.03 divided by 12. What do you get for that? Adriana? Nada? 0.0025. We agree? Okay, now put plus 1. Put plus 1. So that's 1.00 something, right? Next, we're going to do the power. So I want you guys to do, push your power button. Push your power button. It should say answer, right? And then the power. Now, if your calculator doesn't say answer, you just have to type the number in again yourself. But if you have this calculator, if you just push the power button, remember what the last thing was. So we're going to take that answer, we're going to raise it to this power. But before we do, let me tell you what 12 times 16 is, because you have to do that first. I'll tell you, though. 12 times 16 is 192. So raise it to the power of 192. So after you push the power button, 192, and then push equals. All right, so I'm going to ask somebody for that one. Jessica, what did you get for that? $1.61 sound about right, guys? Then you multiply it by 3,137. So just do times 3137. And David, what did you get for that? Does 5066 sound good, guys? Something like that? Okay. So since you're doing this in pieces, sometimes along the way you're going to have to stop and round. Like when I asked Jessica for her answer, she said 1.61, then she kept going. Well, no one wants to write all that out or type it on the calculator, so what are we going to do? We're going to round it and cut it off. And that's where you start getting it a little bit off, right? But before that was the long way. Let me show you the process, though. You guys know PEMDAS, right? I just did PEMDAS. I did parentheses first. I did these two plus 1, right? Then I did exponents, PE, and then I did multiplication, PEM. Okay, so if you're at home on a cell phone, that's the order you go on. Simplify inside first, then do the exponents, then do the multiplication. Now I want to show you guys a more accurate way to do it, which is also faster on this calculator. Because you can actually just type this whole thing in just the way it looks on the board pretty much. So you're going to type 3137, parentheses, 1 plus, now here's where it's different, parentheses, 0.03 divided by 12, that's your fraction, close parentheses, power button, parentheses, 12 times 16. So type this in your calculator just as I've written it up here. This, parentheses, 1 plus, parentheses, that, divided by 12, parentheses, power, parentheses, 12 times 16. Just type it all in at once and push equals. No rounding. And it's faster because you don't got to keep doing piece after piece after piece after piece. You just punch it all in at once. Should be the same thing, though. Because we didn't, on the calculator here, we still didn't round, right? But when you're at home on your cell phone, you might have to stop, write down your answer before you move on to the next step, and then you're going to be rounding and stuff. But we should be getting something like 5066, right? Same answer. So however you want to do it, I don't care. If you do go with a method where you're doing it in pieces and you have to round, just be aware that on a multiple choice test, you're just going to look for the answer that's closest to yours because it won't be exact. It'll be close. Okay? So that's the idea. We'll do another one here. We're going to do number 2 next. If you want to get a head start on it, go ahead. Yeah. 0. But you need 2 parentheses after your 12. Anyone else want me to look at your calculator before we move on? So if you're not getting the 5066 thing, let me know. We can look at it. So there should be another parenthesis after the 12. I don't know why it would be 7, but anyway, that's still good. But another parenthesis after the 12. Because that first one is for that. Maybe we'll go to power there. Oh, so right here you show 12 divided by 12 times 6. So watch those types. So one okay, let's go ahead and move on to a second example. Now, if you didn't get the calculator thing yet, we'll try again. I don't want to leave anybody behind, but I want to go ahead and proceed on with our next one here. So let's go ahead and begin here. Read this first and label each number with a letter, and I'm going to ask you in a second what you guys labeled each one as. Yeah. Kimaya, What would this one be? Great. And do you know what letter that would be? Good. Miles. How about that guy? Cool. And then we have only one more number up there to identify. Aaliyah, this one.
T.
Good. All right, so now go ahead and write out your formula. I'll ask you what to write. So go ahead and write out your formula. Punch it in your calculator and we'll see what you get. And that'll be it for that one. 8.2. Okay, what do you guys think? Do we agree? So, all right, so one more completely on your own. I'm not going to go through all the details. I'll just ask you for the final answer. So go ahead and try one more time, just to really get it solid, and we'll move on to our next part. All right, guys, so that's the answer there. Now, I agree. That's what I got. But if you want me to look at yours and we'll see what's going on there, we can. But that is what I got. Now, here's what we just finished doing. We finished finding the final amount, right? We started with this much, and now we have this much after 20 years, apparently. Okay? So I'm going to do a little bit different this time. With the problems we just completed, I told you what P was. I told you what R was, and N, and T. And so we could solve for A. The next problem I'm going to give you is I'm going to give you T, N, R, and A. I'm going to ask you to find P instead. So in other words, I'm going to give you everything except the starting amount and ask you to find the starting amount. That's it. So it's really not a whole lot different, but I just want you guys to be aware of the question. So this one's saying, what will the account be after 20 years? This one, I'll tell you what the account is after 20 years, and I'll ask you how much did we start with. Okay, that's the only difference. So we're going to skip number 4, and let's jump up to number 5. All right, so let's label these things. Bill invests a sum of money with a retirement account with a fixed annual interest rate of 3%. Katie, what letter is that? It is R. And as a decimal, Jedrick, what would that be? 0.03. Good. Next. It's compounded 2 times. Cynthia, what letter is that? Good. Compounded is the N letter. Crystals, the next one says after 20 years. What letter? Okay. And Armani, you get an interesting one, a different one. It says after 20 years, the balance is this. What letter is that? P. It used to be. P represents our starting amount. This is our final amount.
Is that A?
It's A. Good. So there we go. Look, so now there's no P, but we do have an A this time. We have an ending amount, not a starting amount. So if I take my formula and plug it in, it would look like this. My A value comes first. I set it equal to P, because I don't know what P is this time, so I'm just going to leave it as P. 1 plus 0.03 over 20. No, not 20. Over 2. Times 2 times 20. So I just put everything where it goes. The only difference is instead of putting my money here, this time I'm putting it here because they told me the final amount instead of the starting amount. So that's one difference, is making sure you can tell. How do you know this is the ending amount? Well, it tells you after 20 years you have that much. That's the end, right? In the beginning, if you see your money up here, they're telling you what you start with. Down here, is what you end with. All right. So how do we solve for p? 2 steps. First of all, use your calculators to do this. Just that part there. Oh, yeah, here. All right. So I'm going to ask Amaya, what did you get for that? Okay. Now, just so you know, since we're rounding here, the more numbers you put, the more accurate you'll be. So if I were like taking a multiple choice test, I don't know, I would put like maybe, let's say 5 numbers after the decimal, just to be extra sure. So, okay. That way, because the more numbers you have there, the more accurate your answer will be. All right. So now at this point, I have p times that equals this. P times this equals this. So how do I get p by itself? You divide it. And that's it. So we're just going to divide both sides by this. Over here they cancel, and we should have our final answer there. P equals I'll give you guys a second. There's did you get it yet, Cal? Okay. Yeah, please. Would you mind? So 4482.44 divided by 1.81401. Okay. Are we good? Do you agree with that, guys? Okay. There you go. So it's almost identical. The only difference is the way you set it up. And at the end, instead of multiplying the starting amount, you divide this into your final amount, basically. That's the only difference. All right. So I'm going to let you guys try one like that, and then we'll call it a day. Try number 6 there. All right. So that's that, guys.